Hi, we're going to be going over Unit 12 series, arithmetic and geometric progressions. So let's start off with one of the progressions. It's what is a sequence? You're going to be learning a lot about this, and there are also other types of progressions of arithmetic and geometric. But this is the one we'll start off with first. I think it's the easiest. Okay, so a sequence, basically, as you can see the definition right here, it's an enumerated collection of objects in which repetitions are allowed. So basically what it is that a number sequence is like a pattern of numbers arranged in a particular order according, to a certain rule or a certain set of standards. So we have an arithmetic sequence and we have a geometric sequence. You could probably infer that an arithmetic sequence has something to do with, addition, subtraction, and geometric is a little bit more, maybe multiplication, division. And if you were inferring that, or if you thought that, then you are correct. So arithmetic sequence is the increase or decrease of terms by a constant value. The constant value, I can already give you this term, is going to be the difference. It's going to be the difference. And geometric sequence is the multiplying of a previous term to receive a new term. And that's basically just another way to say that, this is a sequence because one pattern, there's always going to be a certain number or certain value that is in between the patterns of numbers. And the geometric sequence, is called a ratio, its value difference, or its value product. Put that in blue. Okay, so we can move on. So I'm going to give you a practice question right now because really, when you think about it, sequences are not that hard, and to start off with it, to start learning the formulas is the best thing to do first. To be doing a arithmetic sequence problem first, but I'm going to tell you the formula. The formula is this. You have it right here. It is UN equals U1 plus N minus 1 times D. Okay, so it's right here. And this formula is trying to find the nth term of an arithmetic sequence. And the nth term can be specified or it doesn't have to be specified. So they can ask you a question of how many terms are there in a sequence, or they could ask you a question like this: find the 12th term of a certain sequence. And I'd have to say that finding, both are relatively the same level of intensity. It's just that these are always good to start off with, finding a specific term of a sequence. So we're going to do this one first. Again, it's the 12th term of the sequence 13, 19, 25. Now, what you may be thinking is this. I could probably just solve that. I know the difference, the difference between 13, 19, whatever, and I'll just count up to 12. You could, but this is kind of like one of our other PowerPoints in series with binomial theorem. You could potentially do that, but if they happen to change 12 to 34 or to 109, then are you going to count all the way to 109 when they only have given you 3 terms so far? No. So that's why, having this formula is really nice, and inputting your values is just even easier. So that's what we're going to do. So we take this formula, and we know that U1, which is UN stands for the first term, is 13, because this is the first given term. And we know that the difference, D, so D equals difference, is the difference between 13 and 19, and that would be 6. So you have it right here, and we know all of this information, so that's a really good start. We'll highlight this, and we're going to start inputting our values. So this is the main, kind of difficult thing. Whenever you see the formula UN, again, N stands for the nth term. If they did not specify a term, they just wanted to know how many terms, you would leave it as UN. But because they said find the 12th term, you need to input 12 into the nth position of the first UN. So I have it right here. I put 12 in. And then I'm just going to put the rest of my values in. I have 13 for my U1, as it says. And then again, I have another in position, which I'll insert the same 12 into. And they give you the -1. And then the difference part, we've already found, is 6. So I put in 6 right here. So then I just do some basic math, and I get 79. Pretty simple. Okay, so now that was an arithmetic sequence. We're going to go on to geometric sequence. This is same level of intensity, maybe just a little bit different with the formula, but it's still a relatively simple formula. So it says find the number of terms. It doesn't specify how many, but it says just find the total number of terms. In the geometric sequence, 8192 plus 6144 plus 4608 plus then ... which means there's more, but it ends, you see this, it ends with 1458. So whenever it ends, usually you're going to be having to use this number in a significant way. If it just leaves the ... then usually it just wants you to use the first 3 numbers that it gives you, but because it ends, they definitely want you to use this ending number. So let's go over the formula. It is UN equals U1 times R to the n minus 1 power. So you see R, we know that R stands for ratio. I'm just going to write that down right here. And we still have our same in values like we did in an arithmetic sequence. Okay, so what we're going to do is, now that we know, let's calculate our U1, which is our first term. That would be 8192. So we put that right here. And our R value is the ratio. So it's the ratio that is going from 8192 to 6144 to 4608. And what we can see is that it's decreasing. So we'll know that it could be either a negative number, a fraction, it could be a whole number, but what we found out is that it's 3, 4, and you can just put this into your GDC and find it out like that. Okay, so now let's get on with the formula. I'm taking UN, and my UN is going to be used as